There are two design approaches in the solid mechanics or strength of material or mechanics of material. The design approach that is also guided by the famous curve that we have been looking at from the beginning of the course. So this stress strain diagram, this is the stress, this is strain along y x-axis, and then y-axis stress. As we have discussed, this is the yield point, YELD, and this is the ultimate point, and this is the fracture point, and this is for ductile material. Ductile material like steel. The design approach, as we have discussed before, up to this point is the elastic limit. And after that, up to the fracture point is the plastic region. So if the material goes under that area, it will never come back to its original position. So with respect to mechanical properties, we have a distinct, mostly for all ductile material, we have yield point and also ultimate point. So within that yield point, as you can see, there's a straight line, y equals mx type of equation, or we can, in this case, we can say sigma equals E epsilon. Sigma equals E epsilon. From that equation, we can write E equals sigma by E epsilon, sigma by epsilon, or we can write P by A, that's sigma, and then delta by L is epsilon. Now, as you can see, this is derived from that in the elastic region. So y equal mx plus c is in a straight line equation. So we really don't know what happened after that yield point. So what is the equation? And there is no equation. We know that we can use to develop some kind of relationship. So if we think of in a design point of view that we are designing thinking that the material will not go over the yield point, or the yield properties of materials are available, for example sigma y is given, then we can use these equations. However, if that is not available, if we use ultimate strength approach, so this strength approach we can call proportional limit approach or elastic limit approach. Elastic limit approach of material design, where we can apply these formulas. But if we use the plastic limit approach, or in other words, we can say ultimate strength approach, we're thinking that material will eventually break. So most of these equations this we have used, they're not really valid. Still, we can use sigma equals P by A, epsilon, all that. However, for the elastic limit approach or yield strength approach, I would like to call that too, YELD, yield strength approach, where the proportional formulas, they are valid, but for ultimate strength approach it's not valid. Both ways are common in some materials. For example, brittle material, there is no distinctive yield or ultimate. So it breaks right after the proportional limit. It doesn't go under plastic deformation. Glass, for example, doesn't have any plastic deformation at all. So in that case, the yield is basically similar to the ultimate, and that is similar to the fracture strength. In this case, you can do either way. However, for steel materials or ductile materials, most metals, we can have both plastic and elastic approach. For brittle material, there is not much distinction because, as you can see, they're all same point. So we can basically use all these formulas, or we can say ultimate approach, strength approach. Either way, it's gonna work. So that's the two design approach in strength of material.